the metric system, and dimensional analysis. So just like some of the other things we've been talking about with significant figures and scientific notation on Monday and Tuesday, this is another area that you'll be using this entire year in chemistry and in future science classes. Some information on the metric system and measuring. A measurement is a quantitative observation consisting of a number and a unit. So basically you look at something, you get some kind of a number value for it, and you also give it a unit. A unit, another name for that would be a label. So an example being if I have a graduated cylinder and I take a measurement with that and I get 4.50 is the amount, and then milliliters was the unit I was using of measurement or the label that I gave that number. In science, we use what's called the SI system, which is essentially the metric system. In 1960, the SI system was adopted as the international system. The reason that it is SI and not IS is that it actually comes from the French term for international system, and in that case the system is before international, so that's where we get the SI. The metric or SI system is based on increments of 10, so like we have 10 millimeters in a centimeter and that type of thing, and as you go up through each prefix in the metric system you go up by a unit of 10. It all starts in the middle with what are called standard units or base units. For mass, the standard unit is the kilogram, which is a little bit different than maybe what we're used to. The length is the meter. The standard unit for time is the second, and the standard unit for temperature is Kelvin. The reason mass is kilogram has to do, later on we'll learn about some derived units, and it's actually a kilogram that helps us get those different units that measure, like for energy and other things like that. Now, in order to take these units and do calculations with them, we have to do what are called unit conversions, and the method that we use is called dimensional analysis. Dimensional analysis is a way of converting from one unit to another using conversion factors. The basic idea is that you start out with what you have, you take it times some conversion, which is in a sense what you want over you have of what you have, and that will give you what you want. It kind of uses, the idea of fractions where you can cancel out units. If something's in a numerator and denominator, and your remaining unit should be what you want. So an example would be if you want to convert from inches to centimeters. So if I have 7 inches and I want to know how many centimeters that is, I start out with what I have, 7 inches. I set up my conversion, which your conversions can be found on that reference packet that you have on the front there. If you look on there, you can find that there are 2.54 centimeters in 1 inch. So I set up my conversion. I make sure that my units are in the numerator and denominator so they can be canceled. So I take my 7 inches, I take it times my conversion of 2.54 centimeters over 1 inch. When I cancel my units, I'm left with centimeters, and I do the math then, so I'll take 7 times 2.54, and that gives me 17.8 centimeters. Some more information on doing conversions. If you're going to be taking English to metric or vice versa, metric to English, you have various conversions given to you in your reference packet. So use those to do any conversions from English to metric. If you're going to go from metric to metric, then you want to use the stairs that are on that reference packet. So here's kind of a way to help you figure out how to use the stairs. So first of all, you have to figure out what 2 units you're looking at. So if you're looking at kilometers and centimeters, you find those two units. The larger of the units is given the value of 1. So if I look on my stairs, kilometers would be larger than centimeters, so I'll give that a value of 1 for the kilometers. Then the smaller unit is given a 1, and then you give it as many zeros as there are stairs. So again, if I've got 5 kilometers, I want to know how many centimeters. I go to my stairs. I see kilometers are larger, they're higher up on the stairs, so I give that a 1. And then as I count from kilometers to centimeters, I count 5 stairs. So that means I will have 5 zeros. So 1 kilometer is equal to 100,000, or 1 and 5 zeros, centimeters. So now I can set up my conversion. I start out with what I have. I've got 5 kilometers times. I set the labels out. Kilometers should go on the bottom so I can cancel those. Put centimeters on top. Now I put my number values in. 100,000 centimeters are in 1 kilometer. Cancel out those kilometers and left with centimeters. Now I can do the math. I take 5 times 100,000, and that gives me 500,000 centimeters. Now make a large note here, or a big star. You need to be careful though if you're dealing with cubed units, and we'll be getting into this in another day or so here. If we're doing with cube units, you have to cube your conversion also, and like I said, we will be doing more of this in another day or so. Once your notes are completed on Edmodo, I also have a sheet of it's a PDF of what you should put on your stairs on your reference packet. So once your notes are done, you need to take the information from the metric stairs on the Edmodo and put it on your stairs on your own reference packet. Then you can take some time to work on your homework. Good luck, and I'll see you tomorrow.